An erudite, organic chemist leading the path to the future development of chemistry, Victor Grignard. François-Auguste Victor Grignard was born in the small town of Cherbourg, France, on May the 6th, 1871. Grignard joined the École Normale Spéciale in 1889, but the school closed down, forcing him to join the University of Lyon instead. Unable to complete his licentiate examination in mathematics, Grignard joined the French army and served from 1892 to 1893. Demobilized from the army in 1894, Grignard got his degree, the licence et sciences mathématiques, by 1894.
Grignard's largest contribution to chemistry was the discovery of the Grignard reaction, as well as the Grignard reagent. The Grignard reaction is important as it is one of the most simple, efficient, and effective ways to create carbon-carbon bonds. It has allowed chemists to further their research by enabling them to create more complex carbon compounds. The Grignard reagent, on the other hand, is an organic compound with a magnesium halide attached to it in the formula RMgX. The main purpose of the Grignard reaction is to add the organic component of the Grignard reagent to an electrophilic carbon on an organic compound. It is usually an addition of the Grignard reagent to a carbonyl group, such as a ketone. Here is the mechanism for the addition of a Grignard reagent to a ketone. The carbon attached to the magnesium in the Grignard reagent is more electronegative and will serve as the nucleophile in the Grignard reaction. The carbon attached to the oxygen will be more positive as oxygen is more electronegative, so it will function as the electrophile. The nucleophilic carbon will attack the electrophilic carbon, and the organic component of the Grignard reagent will be attached to the electrophilic carbon. One of the electrons in the oxygen-carbon bond moves to the oxygen as the carbon cannot have an expanded octet. After that, there will usually be a final step in the form of an acid workup to neutralize the product as the oxygen is still negative. It is usually an addition of a hydronium ion to the product, resulting in alcohol and water. The magnesium halide remains as a positive spectator ion. Grignard reactions are important to chemistry as they are a simple and easy way to make carbon-carbon bonds. There are few other methods that are effective as the Grignard reaction. Many more complex carbon compounds can be created with the Grignard reagent. It can be used for many applications, including but not limited to attacking carbon dioxide to form carboxylic acids, opening epoxide rings, forming alcohols, forming amides, ethers, ketones, and aldehydes. His application of these reagents were cited over 6,000 times at the time of his death. For these reasons, Grignard reagents are important compounds for organic synthesis in chemists' research.
Grignard served his nation in another way as well. After the onset of World War I, Grignard rejoined the French army, this time as a chemist who greatly contributed to the mass manufacture of phosgene. Phosgene is a colorless gas produced when chlorinated hydrocarbons are exposed to heat. It was historically weaponized in both World War I and II. It smelled of damp hay at low concentrations, with an increasingly pungent odor as the concentration in the air increased. During World War I, trench war was a method of entrenchment utilized greatly by both warring parties, that being the Allied versus the Central Powers. To force enemy combatants outside of their trenches, phosgene was released with the hopes of having the toxic gas blown over into the enemy side. In the concentrations those enemy soldiers were exposed to, it would first act as an irritant to the eyes as well as mucous membranes, such as the nose and throat. However, unlike other chemical weapons utilized in trench warfare, such as chlorine and mustard gas, a lethal dose could easily be absorbed before the enemy combatant could even realize their own doom. As a result, phosgene weaponization in World War I would account for the vast majority of chemical weapon fatalities.
A figure of 85% of all chemical fatalities, right?
Yeah, about 85%. Phosgene's most serious and severe symptoms would often come up days after exposure, predominantly manifesting as pulmonary edema or fluid buildup in the lungs. The doomed soldiers would spend their last hours futilely gasping for breath as they slowly drowned in their own mucus. For his contributions to the mass manufacture of phosgene in France, Grignard would be awarded the Legion of Honor, France's highest military award. As this award was paid by the gruesome, agonizing deaths of many, from a historical perspective, it is arguable whether or not Grignard's legacy in this line of work, that being the line of work regarding chemical weapons, is to truly be admired at. However, after its horrific history in both world wars, phosgene in modern times is used predominantly in the production of polymers, including polyurethanes and polycarbonates, plastics in many industries, from bottling and sponge making to glass alternatives. Victor Grignard's work had wide-reaching implications for the scientific community. The ability to attach a vast plethora of molecules such as alkyl and aryl magnesium halides to the carbonyl groups of aldehydes and ketone functional groups allowed many fields to synthesize new materials previously unfathomable. Specifically in the realm of organic synthesis, the Grignard reagents proved, and still prove to this day, exceedingly valuable. In the realm of organic synthesis, Grignard's work gave scientists, in very specific circumstances, in analogy, the ability to quite literally glue things together to form what they wanted. Onwards of its discovery, Grignard reagents are still used in a wide array of industries. For instance, the medical industry is able to still research and create new medications as a result of Grignard reagents. In another example, such as within the agricultural industry, the reagent is utilized to help create eco-friendly soil. Here's a dive deeper into what all of this means.
The Grignard reaction is utilized as a key step in significant pharmaceutical syntheses such as tramadol, naproxen, ibuprofen, aprepitant, droloflexin, and tamoxifen. These drugs are important in combating many diseases. For example, tamoxifen is used to treat breast cancer, naproxen is used to reduce arthritis symptoms, and ibuprofen is used to help with headaches. Over 100 years later, his discoveries still lead the charge to further improve life quality for all humans. Without the Grignard reaction, it would be much harder to produce these drugs. The Grignard reaction is also used to make compounds used in perfume. Victor Grignard would be born on May the 6th, 1871. From 1892, he would perform military service in the French army. He would retire as a corporal in 1893. In the year 1900, he would discover the Grignard reaction and reagent. In the year 1912, he would be awarded the Nobel Prize for the Grignard reaction and reagent along with Paul Sabatier. In the year 1914, World War I would start and Grignard would be mobilized again, commissioned to study cracking basils and eventually chemical warfare. Up until his death, he would work on the Traité de Chimie Organique, known as the Treatise on Organic Chemistry, as well as working as the professor of general chemistry at Lyons. Grignard would eventually die on December 13th, 1935.